So they thought that the population mean was 4.5 hours per week. They went and took a sample, and the sample's a little bit higher. So now they're trying to decide whether they're wrong and that the actual mean amount of time on the phone is larger than what we think. So the null hypothesis is the status quo hypothesis. That would be that the population mean is still equal to what we used to think, 4.5. Our sample is evidence that it's higher, but is it enough evidence to claim that we've increased our phone usage? That's the test that they're trying to conduct. And the test we're trying to conduct is always the alternative hypothesis. So that's what we need here, that the population mean is now greater than 4.5. This is the sample mean. You don't put the sample mean in your hypothesis statement. And then this one is out because we're testing to see whether it's greater than 4.5. The sample mean is higher, so that's pointing us in the greater than direction, not the less than direction. Okay, statistics students believe that the mean score in the first is 65. Statistics instructors think the mean score is higher than 65. Okay, so right there, before I even go on, I know my hypothesis statements. Mu equals 65 is our null, because that's the old one, and the alternative hypothesis is that mu is now greater than 65, because the hypothesis statement we're trying to test is that the mean score is greater than 65. The hypothesis statement we're trying to test is always the alternative hypothesis. Okay, so he samples some data. Okay, they've already done all the legwork for us. They got a p-value. The p-value is less than 0.05, which is 5%. If the p-value is low, reject HO. Okay, we reject the null hypothesis in favor of the alternative. If the p-value is above 5%, which is 0.05, then we do not reject. So this one we reject because the p-value is low.